Hi, in this video we will do more examples for the matrix multiplication. And well, if the matrix multiplication is given, we will find the entries. A and B are given. A is 3 by 3 matrix, B is 3 by 2 matrix. Then we go ahead and try to see if AB is defined or not. Means what? To check if matrix multiplication is defined, we do the compatibility. This is 3 by 3 and this is 3 by 2. The number of columns of the second one and the number of rows of the first one are the same. In other words, the closer indices down there are the same. That means it is defined, and the result is going to be a 3 by 2 matrix. 3 by 2, it means that we will have three rows and 2 columns. We have to find the entries here. So to find the first row, first column entry of the product, you have to pick the first row of A, which is 0, 1, -1, and make it in the vector form, and the first column of B, 1, 0, 6. Find the dot product. First row of A dot second column of B. First row of now the second row of A dot the first column of B. So this and that. Yes, and then 2, 0, 1, second row and second column, which is 2, 4, -1. Let me write this one. 1, 2, -1, the third row and the first column, the third row and the second column. So these are just dot product here. So here I have 0, 0, -6. Well, let me write it in the final matrix, and we move to the next one. The final matrix, the first one. The dot product of these two. 0 times 1 is 0, 1 times 0 is 0, and -1 times 6 is -6. 0 times 2 is 0, 1 times 4 is 4, -1 times -1 is 1, so add those ones, this is 5. Then you do 8 here, and then you do the product, and you get another 3, -5, and 11. Yeah. So this is that 3 by 2 matrix that we knew from the beginning. The product must be. How about BA? Well, B is 3 by 2. A is 3 by 3. And as you can see, the closer indices are not the same. So this is not defined. Oops, it's not defined. So we don't need to avoid anything about anything else. That's not. How about B transpose? See, B is what? 3 by 2. And B transpose will have the opposite of these ones. So 2 by 3. Now you see these two are equal. The result will be a 3 by 3 matrix. So I will take this one. This is going to be a 3 by 3 matrix. And how do we get these ones? The first row, let me just copy that matrix and bring it down here. I will need that one. Copy. And give it here. Paste here. Okay, there. Yeah. So for first row of B, which is 1 and 2, first row of first column of B transpose. What is B transpose? Let me write down the B transpose. B transpose is 1, 2, 0, 4, and 6, negative 1. Now you see 1, 2 times 1, 2. Well, dot product 1, 2. 1, 2 dot 0, 4. And 1, 2 dot 6 and negative 1. Then the second row, 0, 4 dot 0, 4 dot 0, 4 dot. But for the first one, you could use the first column, second column, third column. For the third row entries, you have 6, negative 1 dot 1, 2, 6, negative 1 dot 0, 4, and 6, negative 1 dot 6 and negative 1. Now the entries are, we have 9 entries. Yes, these are 1, 2 times 1, 2. This is 1 plus 4. This is 5. The other one is 8. The other one is 6 minus 2, 4. The other one is another 8. The other one is 16. Negative 4. 6 minus 2, 4. Negative 4. And then 36 plus 1, 37. That is B transpose. How about A multiplied to A? So A is, what is A? A was, okay, I can write it here. So A is 0, 1, negative 1, 2, 0, 1, 1, 2, negative 1. We want to multiply it to itself. Oh, to itself. 0, 1, negative 1, 2, 0, 1, 1, 2, negative 1. Okay, so we are, first of all, it is defined because the number of rows and columns of A are the same, and we are going to have a 3 by 3 matrix. So we have to compute 9 entries. So the first 1 entry is first row, first column, dot product, those ones, 0, 0, plus 1 times 2, and plus negative 1 times 1. Then the second one, first row, second column here. You get 0 times 1 plus 1 times 0 plus negative 1 times 2. Well, I'm just going to leave everything here for you and write the final result here. Just do the multiplication yourself. You will see that these entries will pop up. So when you first check the compatibility and then the dimensions you find, you have to be able to compute the entries. And depending what are the dimensions, we will have different dimension product.